This is lecture 4F for Calculus 1 on business optimization. There are many interesting applications for calculus in business and economics. There's supply and demand, there's logistics, all kind of really interesting problems. All I'm going to look at here is just the very basic break-even type of analysis. And I'm going to go over this just for people who haven't had the terminology before, haven't been exposed to it before. So in business, we're going to divide things into cost, revenue, and profit. The costs are going to include, let me get the marker, they're going to include fixed cost. A fixed cost is your rent, your manager's salary, anything that you have to pay, even if you have shut the doors to your business and gone to someplace nice like Montana for the month. Okay, you're going to have to pay those anyway. Those are your fixed costs. The variable cost, the cost is what it costs you to do business. For example, if you pay $35,000 a month for your factory, and it costs you $105 per item to make your items, that would be all the raw material, labor costs, etc. Or if that's what it costs you to buy them, to purchase them for resale, that's how you divide your costs. Fixed costs, there's no X in it. It's just a fixed cost every month. The other will have the X, meaning that the costs are going to go up depending on the number sold, manufactured, purchased, made, tickets sold, whatever it is. Number of tourists you take someplace, that's your X. The revenue is simply the money you bring in from the sales, and the revenue is calculated as price times the number of things you sell. That's just very basic revenue. Revenue gets very complicated, especially if you are offering discounts. You'll end up with quadratic terms, so it can be very complicated. In fact, when you're doing the business problems, writing these revenue and cost equations sometimes is the hardest part, especially writing those revenue equations. It can be very hard. Okay, profit is simply the difference between revenue and cost. Notice it could be negative. If it's negative, it's a loss. If it's positive, it's a gain, but we can still call it a profit for the whole thing. So the location of the maximum of profit is an optimization problem. Okay, the minimum value of cost, that's an optimization problem. Maximizing revenue is another optimization problem. And all these are approached in the same way that the more engineering or physics-oriented problems are approached. Okay, say we want to optimize profit. Well, here's our main equation. Profit equals revenue minus cost. This is already in a nice form because there is only one variable, the number of items bought or sold. We've already written it down in one variable, so that middle step that was hard to handle when we were trying to carry the ladder around the corner or design the rain gutter, that isn't here. You've only got one variable x, and so that's really good. Now you can take the first derivative, and there's a name for them. The first derivative of profit with respect to the number sold, it's called marginal profit. First derivative of revenue with respect to the number sold is marginal revenue, and no surprises here. The first derivative of cost with respect to the number sold, which is x, is marginal cost. Unfortunately, I can't read, so you can sort those out for yourself. Marginal is first derivative with respect to the number sold. Sometimes you will see that used in a crude sense where they just divide by x, but it really is the derivative. All right. So now at the critical point, the profit is zero. The marginal profit is zero, meaning the rate of change of profit with respect to the number sold is zero. That's the critical point. So once you have your equations, you can just take the derivative. What happens if you have linear costs and revenue? Okay, the slopes of these linear functions is constant. There is no point where the marginal profit is zero. The profit is never maximum. In this case, the more you sell, the more you make after you get past the break-even point. If you have nonlinear cost and nonlinear revenue, or even just one of them is nonlinear, then the maximum profit will occur where the derivatives of cost and revenue are equal. Remember that the break-even points were the points where revenue equal cost. Now I'm saying that the maximum profit occurs where the derivatives are equal. When revenue equals cost directly, those break-even points, profit is 0. When the derivatives are equal, the profit is at a maximum. You hope. So once you have the critical point, which would be the value of x for which the first derivative of profit is 0, you need to evaluate it. Is it a maximum or is it potentially a local minimum? And you can do that two ways. You can take the second derivative and look at the sign of the second derivative. If the second derivative is less than 0, then you have a maximum. That's because the curve is concave down. If the second derivative is greater than 0, then you have a minimum because the curve is concave up. There is this other way to evaluate it without taking that second derivative. Maybe you don't want to. All right, let me. Okay, this other way is to look at the signs. Look at how the first derivative behaves as you go from right to left past a critical point. If you are going down towards a minimum, then the first derivative will be negative, gets to the minimum, first derivative is 0, and starts coming back up, first derivative is positive. So if you look from left to right, you look towards increasing x, and look at the behavior of the first derivative, you can also identify whether you're at a minimum or a maximum. Of course, you might say, why don't I just plot the curve on a graphing calculator and eyeball it? And that's a possible thing to do. You could, in fact, get a lot of information doing that. But to really find that value, you need to set that first derivative to 0 and evaluate it. To decide if you really have the minimum or the maximum, you need to compare the values, these critical values, with also the values at the endpoint. For most business problems, the domain is 0, usually included, because it's possible you sell nothing or make nothing, and there's usually no upper bound to it. So all you need to consider is to evaluate the function at x equals 0 and see if that is a better maximum or minimum for your problem. In the next 3 lectures, then, 3 of them will be minimizing and maximizing cost and profit for businesses.